Hello everyone, welcome to the Introduction to Mechanical and Industrial Engineering course. This is the second video of part 3 of the mechanical design. In this part, as we discussed over the previous video, we are interested in covering these 2 points, which are the unit system and conversions and how we can convert from one unit system to the other or between the same unit system, also the force analysis. Over the previous video, we have discussed the unit system in detail. And today's video, we are going to introduce for the force analysis, and this part will be covered over different videos. So in today's video, I'm just gonna introduce what does it mean force, and we're gonna fix some important concepts which are related to the force analysis or forces from the physics point of view more than being from the engineering point of view. But anyway, this is what we have discussed over the previous video. We discussed what does it mean a physical quantity and the difference between a physical quantity and physical phenomena and the different types of physical quantities that would have base quantities, driver quantities, and we discussed their unit systems. And we do have 2 unit systems, the international unit system and the American unit system. Also, we discussed the basic quantities, which are 7 quantities like length, mass, and time. And we said that these are the 3 that we're going to focus on through this course. Then we discussed their corresponding units, basic units for all of these 7 quantities in the SI unit system or the American system or the US system. Then we discussed how we can do conversion from or define the units for the different driver quantities like area, volume, density, velocity, acceleration, and force. So the focus again over this video is going to be over this force. So this means that the force, it is a physical quantity. And we said that any physical quantity to be fully described, it should be defined by a number, by a value followed by a unit. So the unit, it is a big deal when you describe and talk about the force. So the focus again over this part is just over this physical quantity, which is the force, and we're going to explain it in detail. Also, we knew how we can do conversion and how we can use the prefixes to convert from one unit to the other. This is what we have been covered over the previous video. In today's video, we're going to talk about the forces. And since we are mechanical and industrial engineer, and the focus of this part is that the forces or mechanical design, it means that we should understand the forces that would exist between the different mechanical components that would be used for making a machine. We have covered these mechanical components over the previous videos. We discussed the shafts, the gears, the clutches, the bearings, and everything. Like for example, if we're gonna consider the gears, we said that one of the gears should be driver, the other one it should be driven. So the driver, it should push the driven to rotate it. In order to rotate an object or rotate a mechanical component inside the machine, we require a force. And this force, it should be generated between the different components that make this machine as a machine. We said that what distinguishes a machine from a bridge is that this machine should contain some mechanisms, some mechanical components who are moving. In order to move any object, this is from physics. Here we are talking physics. In order to move any object, you have to act on this object with some forces. This forces should be big enough to push this object. Like for example, if there is a box on the ground, and I ask you to push it or move it, so what you should do, you should push this box with a certain force to move it. How about if the force that you are acting or subjecting to acting on the box, it is not big enough? This box won't gonna move. So you should act with the force. So this is the objective of this part here, is to know how much of force needed to give a motion or a push to an object. What is the force that should be generated between one gear and the second gear, the other gear? This is the physical meaning of, or this is the importance of forces. One of the essential steps of the design of any mechanical component is to do force analysis, is to understand the forces that exist between the driver gear and the driven gear. That the driver gear, for example, should push the driven gear with a certain force. This force, it should be big enough to give rotation to the driven gear. Otherwise, the driving gear will not be rotating. So how much of force is needed and how we can calculate this force, this is what you're gonna study in detail when you study the mechanical design courses after 2 years or something. It means that in this part, we won't gonna go how, or I will not explain to you how we can calculate the forces between gears, but at least you should understand there should be some forces somehow exist between the gears, between the shafts, between the bearings, or the mechanical components inside the machine. There are some forces generated between them, and these forces are important to move all of these mechanical components inside this machine. But the objective here is just to explain what does it mean force to you. How we can do some simple calculations to calculate the net forces, the resultant forces acting over any object. How we can do force decomposition or analysis. How we can do some simple force analysis. As I said, this is the main objective of this part, is just to give you an overview about this topic, which is force analysis. What does it mean? Make sense? But again, we will not go through the calculation of the forces between the gears, how we can calculate these forces between the spark gear, for example, and the bevel gear or the helical gear. These things will be discussed in detail in the mechanical design course. Make sense? But the objective here, and this is what I'm gonna talk about here. So I'm just gonna talk physics. In these few slides, or over this video, I'm just gonna focus more on the physics. What does it mean, a force? Okay, so what is a force? Or what is the force? For example, I'm pretty sure that you have known this term before. Even you are using this term, whatever, in the high school or in other courses like physics, mathematics, or whatever. But if I ask anyone what is a force, probably you could struggle to explain what is this force exactly is, okay? But there is a simple definition of the force that is anything that tends to change the state of an object, it is a force. Anything, yes, anything that is the intention of this thing is to change the state, this is the key word, of an object. So what is a state? For example, if you do have a box like this box as shown in this image, this box is stationary. It is not moving. So this is a state. So if I ask you to describe the state of this object, it is stationary, it is not moving. This is from the mechanics or from the engineering point of view, that it is just stationary. We may have another box or another object that is movable, that moves. So we're gonna say that it's a state that this object is moving with a certain velocity, with a certain acceleration, and we are going to describe the motion of this object. So we do have two different states here. One state that the object is stationary, that we used to give it a name as static, okay? And we're gonna give another hint about the static after a while. The other case that this object is movable, moves. So we're gonna say that this object is under dynamic motion. It means that this object is moving. So these are the moving object, but this one like stationary object for now. It is not moving. If you have a box, it has these two options, right? It is either stationary, not moving, so we're gonna give it a name as a static. The other case, it is movable. It moves with a certain velocity and acceleration. This is known as the dynamics. It has dynamics. So that's why in your curriculum, you are going to study engineering mechanics, as we discussed before over the previous videos. We said that one of the subjects that you should study is engineering mechanics. Engineering mechanics, it means that you should study the statics and the dynamics of objects. So there are two courses that you are going to study in your curriculum for mechanical and industrial engineering. One course is named statics. In this course, you are going to study all objects who are under static condition. Static condition, one of these static conditions is that this object is stationary, it is not moving. Like a bridge, it is fixed in place, it is immovable. So like a structure, like a bridge. This is one course. There is another course that you are going to study the engineering mechanics or the mechanics of movable objects, that you are going to study the objects who are moving. Whatever the object is stationary or moving, this is known as a state of this object. In order to change the state of this object from being stationary to be movable, or the movable to stop to be stationary, you need a force. So the force is an interaction or anything that is going to change the state of an object. It is a force. Very simple. This is what does it mean, a force. Or in other words, if you have a box that is stationary in place, not moving, and I ask you to move it, what you're gonna do? The first thing that you're gonna push this box, right? The pushing that you're gonna give to the box, it is a force. Why you push the box to move it? Because I need to change the state of this box. To change the state, you require a force. This force, it will be represented in terms of the pushing that you're gonna give to the box. If you push the box, you are acting on it with a force. This force, it should be big enough to move it. So you are changing the state of this box from the static to the dynamic, or from the stationary state to the moving state. So this is what does it mean, a force. The same thing, how about if there is a box that is moving and I ask you to stop it? So what you're gonna do, you're gonna start and for example, it moves to the right. So you're gonna go very quick and try to push against the direction of motion of the box to stop this box. So the force that you push against the motion of the box, the tendency of this box is to change the state of this box or this object. So it is a force. And after a while, this box is going to stop. So the tendency of this force is to change the state of the object from being movable to be stationary. This is what does it mean, a force. Very simple. Okay? So this requires, actually, to understand it more or further, this requires that we have to bring here the Galileo's assumption and the Newton's first law to explain these two concepts from physics and understand the difference between them. Galileo's, for example, assumption is state that it is not the nature. This is what it is state. Then the nature of any object like a box, like the car, like the machine, like anything, whatever it is, to stop it means that this object is already moving. You got my point? Like it is not the nature of an object who is already moving to stop once set in motion, but rather it will continue in its original state of motion. So just to understand this assumption or this concept very quick, it means that according to this assumption, if there is a box that is already moving, this box will never stop. It will never stop. Do you think that this is logic, or does this make sense? No, because if there is some friction over the surface between the box and the ground, definitely is going to stop. If some guy, for example, on the other side, for example, you're gonna give a push to the box, so the box is going to move. Is this box is going to move forever? No. But the Galileo's assumption or theorem state that if any object is in motion, it means that this object has been pushed to move. It will never stop, which doesn't make sense. Anyway, objects in reality, they are going to stop whatever instantaneously, or it's gonna take time to stop this object. Anyway, it will stop. Like you're driving the car, it's going to stop after a while, right? So according to the Galileo's assumption, if we push this box, which is shown in this image, will not stop and will continue moving forever. This is not accurate and this is not acceptable in all cases. This is acceptable under only one condition. What is this condition? In case that the net of forces acting on the box is zero, yes, this box is going to continue to move. So again, Galileo said that if you pushed this box, it's going to move forever. This is not acceptable, or doesn't make sense. This doesn't make sense in all cases. It makes sense only under one case. In case that the forces acting on the box, it is zero. Why? Because the tendency of any force is to change the state. So if this box to continue moving the same way as it is started, it means that the forces acting on the box, it should be zero. And this is happening in case that this box is moving under a very smooth surface. There is no friction, there is no air resistance, there is nobody who's going to stop the box. It means that there is no forces at all that would act on this box to stop it. So this box will continue moving forever. This is according to the Galileo's assumption, and this assumption will be valid under only this condition. But there are some other cases or scenarios that this assumption will not be valid anymore. In case that there is a friction, definitely the box is going to stop. The air resistance, even, it is a reason to stop this movement of the box. It means that the net of the forces, in reality, it cannot be zero. It means that there should be some net forces acting on the box, and that's why after a while it's going to stop. It means that Galileo's assumption, it is not valid all the time, and we need more accurate assumption or theorem. And that's why Newton has corrected this concept and drive it or developed the Newton's first law. Make sense? Newton's first law, for example, states that an object, this is more accurate statement, an object moves. It means that the box is already moving with a certain velocity. Move, it means that it has a speed, a certain acceleration in some cases that is constant. But this is the condition here, that this velocity is constant in magnitude and direction. So what does it mean, magnitude? Magnitude, it means that the value of the speed. Velocity, it means speed. You're gonna push the box. This box is going to move with a certain speed. So the speed, it is fixed or constant in magnitude. Magnitude, it means that the value of the speed. Like, for example, if you drive your vehicle and the speed of your vehicle, it is, for example, 100 kilometers per hour. So this is a speed, this is velocity. You can cruise, there is the cruise in your car while you drive, and you can cruise and fix this velocity, right? You can fix this speed. You can, for example, switch the cruise in your car to the 120 kilometers per hour. It means that the car is going to move at this constant velocity. So assume that you have your car is moving at this constant velocity for some reason, like the box moving with a constant velocity as a value. And direction, it means that you are going in a certain direction. So this object that moves with a constant velocity that is constant in magnitude and direction will continue to move unless a non-zero force acting on it. So what is the difference between this one and this previous one? Galileo said that if you have an object that moves in general, this object will not stop. But this is not valid. We said that there are some other scenarios or cases that this object will stop because of friction, because of air resistance or whatever. But according to Newton's law, which is more accurate statement, that if this box is still in motion under constant velocity and acceleration, it's gonna continue to move unless you are acting on it with a force which is bigger than zero. That the net force acting over this object, if it is bigger than zero, it means that this box is going to stop. Or this force, which is bigger than zero, is going to change the state of this object. What is the state of the object? It moves with a constant velocity and with a velocity that has a constant magnitude and direction. But to change the velocity, or to change the box from being moving to stop the box, it means that you need to change the state of the object. You require a force. So the force is something needed to change any state of any object, whatever it is under static, to be movable, or even if it moves with a certain velocity. For example, if you have a box that moves with a certain velocity, and the net of forces acting over this box, which is already moving, is zero. So the speed of this box will not change. But in order to change the speed of this box, you have to act on it with a force. Whatever, if the force in the same direction of motion, so it's going to speed up, like you push more. Or if the force direction against the motion of the box, it means that you're gonna slow it down. It means that the speed is going to decrease. So to change the state, to change the speed, to change the object from being stationary to move it, you require a force to change any state of this object. And Newton's first law is more accurate than Galileo's law for this assumption. Okay? So I'm just gonna show you very Very nice game that you can play and try at home even. I'm just gonna show you something to explain these four things with more detail. Then we're gonna move to the different types of forces. Okay, so let us consider this application that you can Google it and find it over online. So in this application that this guy, he's gonna push this box. And there should be some roughness over this surface, which if you can see it, it is a very slight roughness that found there over this surface. And let us set here the forces, values, masses, and speed. So this is the speed of the box. Currently the speed is 0 meter per second. The speed is distance per unit time. So that's why the unit is meter per second. Now at the current state, this box, it is stationary. It is in static, it is not moving. And as you can see, the net force or the sum of the forces acting on it, it is 0. There is no forces acting on it. This guy is somehow apart from the box, he's not pushing it, so there is no force. But in the meanwhile, there is a roughness, right, over the surface. And this roughness over the surface, or this rough surface, is going to generate some friction. So it is going to generate some resistive force that is going to resist the motion of this box. But at this instant of time, this friction, it is 0 as well. Why is 0? Because the friction force, and this is one of the specifications of this friction force, that it generates as long as the object is going to move, or the object has the tendency to move. But since there is no tendency for this object to move, so there is this frictional force, it is still 0. But this frictional force is going to build up and increase as you try to push. So that's why, for example, if I try to push this box with a certain amount of force, let's say like 5 or 10 newtons, for example. So I'm increasing, so the guy start to push the box. But unfortunately, the box, it is too heavy. It is 50 kilograms that generates certain frictional force. So as you can see, the applied force, it is 10 Newton. He pushes with 10 Newton. The ground is going to generate a frictional force that push against the applied force. The applied force is you're pushing. The frictional force, it works against this applied force. So that's why the sum of the forces, it is still 0. 0, it means that you are applying a force and there is another frictional force that cancel your effect. You try to push and there is something else who cancel your effect. So that's why this box is not moving. So in terms of physics, or according to Newton's law, we don't care about how much of force that you are exactly acting on the box, but we care about this sum of the forces. We still have 0 sum of the forces. That's why this object is not moving. That's why this object is not changing its state. There is no force acting on it that is big enough to change the state of the box. The box, its current state, it is stationary, has 0 velocity, has 0 speed. That's why it is not moving. The speed indicator is not changing. Why? The sum of the forces is 0. But I'm acting with the force, yes, but your force has been cancelled because of the friction. So you need to increase the force more. If I increase the force to 60 Newton, I'm still not moving. The frictional force has been built up more, from 10 to 60, to cancel my applied force. It means that the net force is still 0. The state of the object is not changing. It is still the same. How about if I increased 150, 120, still 0, increase more. Now it start to move. Why it start to move? The sum of the force, it became 66. I'm applying 160 Newton, which is bigger than the 94 Newton as frictional force. So the difference gives us 66 Newton, which is a big force, big enough to keep pushing this box. As you can see, the speed is going to increase. This guy, he is programmed to leave this box when the speed reach the 40. So at the 40, he left the box, what should be happening now at this case? So there is no more pushing to keep this box moving. So the only force that is remaining is the frictional force, and the tendency of that force is to stop. That's why this slow is down, slow is down. So I'm going to change the state from moving to stationary because of the force. So this explains that Newton's law, it makes more sense. As long as the force acting on objects are bigger than zero, you can change the state of the object. But if the force acting over the object, it is not bigger than zero, or the sum of the forces it is zero, it means that you cannot change the state of this object. Make sense? So for example, how about if I decrease the friction? There is no friction, like icy surface, there is zero friction. There is no frictional force. So in this case, in a little bit push that you're gonna give, let us start over. Like any small push that you're gonna give to the box is going to move it. Why? There is no friction. So even if you just give it 1 Newton, it's going to move. As you can see, the speed has been increased and is gonna continue to increase, but it's gonna take time to speed up. Why? The force is too small. How about if you would like to speed up faster? So the net force here, it is 51 Newton. There is a sum force. The sum of the forces, it is bigger than zero. It means that you are going to change the state of this object. That's why instantaneously the speed is going to change. How about, for example, if I decrease this force to zero? It means that I ask this guy to leave it. So the net force, it is zero. There is no force. But what is the current state of this box? It is moving at this speed, which is 20.2 meters per second. But since the sum of the forces is zero, this box will continue moving forever. It won't gonna stop. Why? There is no forces acting on it. There is no force that is needed to change the state. There is nothing, it changes the state of this box, so it's gonna continue to move. This fits with the Galileo's assumption. Galileo's assumption is valid under only one condition, one state, one scenario, which is this one. Under this case, Galileo's assumption works. Why? This object that has been set in motion will continue to move and it will not stop it will not stop forever. But this statement is not accurate. The accurate one is Newton's law. As long as the sum of the forces is zero, the state of the box will not change. How about if you would like to speed it up? So you need to apply a force. You're gonna push more, so it's going to speed up. Observe the speed. It's going to speed up. If you decrease the force to zero, so the speed will be fixed at 28.2 because the sum of force is zero, so it's gonna maintain and keep this state forever. Unless you are acting with another force that makes the sum of forces bigger than zero. How about if, for example, if I decided to stop, how we can stop this box? Add some friction to the surface. If I added some friction, as you can see, like this friction, so the sum of the forces is directed to the left. And there is a friction force that has been built up, and that's why it slowed down. I'm changing the state. I'm keep on changing. The speed is keep on changing. I'm keep on changing the state of this box till it will be completely stopped. Make sense? So this is what does it mean a force and the importance of the force. So generally speaking, a force is something that is used to change the state of object from stationary to moving, or even change the speed. If the object is already moving and you would like to change the speed of this object, that is fine, we can do it, you need a force. So you can apply, that's why the force here is a big deal. It is very important thing to acknowledge the importance of the force. And if we're gonna talk about the mechanical design things and the engineering application, like inside the machine, as I said, the gears, if they are already stationary, and in order to enforce these gears to move or ask them to move, it means that you need to change their state. To change the state of this mechanical component, you require a force. So this is the importance of the forces in the different engineering application, and this is what does it mean a force. All right, so as we said, a force, it is an interaction that tends to change the state of this object. Or simply we can say that the force, what makes object moves, or what makes or prevent the motion of an object. So all of these are forces, like different definitions of forces, but the simplest and the accurate definition of the force is as represented by Newton's law, that the force is something that tends to change the state of the object. And in fact, we do have, in terms of engineering application, we do have so many different types and forms of forces. We may have this force as mechanical force, like the spring force. So this is like a spring force. Like you try to push or to stretch a spring, or even to push or compress a spring. So this is a spring force. It has some specification that you're going to know about it with more detail when you study the statics and the dynamics class. Also, the force, it could be in the form as a tension force. Like you do have this rod, and this man tries to pull the cart that have the baby. So this cart and baby has a weight, and it means that you should apply with a certain force over this cart to push it or to pull it to move. So this pulling or this force, there should be a force that is going to generate in this rod or this wire. This force is known as tensile force. Also, the force like this is tension force. All of these are different forms of mechanical forces that we are giving them a name as a mechanical force. This force also is another form of a mechanical force known as impact force. Impact force, it means that this guy tries to hit. If you hit something very suddenly, very quick, that you apply the force instantaneously, at instant of time, and that's it. But for example, this tension force, it is continuous. As long as this man is moving, right, and keep pulling this cart, so the tension force, it is there. So this tension force is going to be applied over this rod or this wire for a period of time. The same thing like the spring force. You are stretching the spring and you're going to keep your hand for a while. It means that this force is going to be steadily and continuous for a while. Then after that, you can release your hand. It's up to you. But anyway, it will not be a sudden force. But when you try to hit a football or a soccer ball or any object, hit any object, like you threw something in the wall. So it's going to hit to the wall directly. This bouncing or this hitting to the wall, it is happening suddenly at instant, one instant of like a part of a second. It takes a few parts of seconds to accomplish this hitting to the wall, or the foot is going to hit to the soccer ball or the football to kick this football. So it is an impact force that takes a while and suddenly removed. So just apply it suddenly at one instant of time. This is known as impact force. Generally speaking, the impact forces, their effect is bigger, much way bigger than the tension forces or the forces that apply it for a while. So this, despite they are still the same forces, both are forces changing the state of the object, yes, but the type of the force is different. The impact or the effect of the force is different. So the impact force, it is one form of the mechanical forces that is different than the tension force, that is different than the spring force. Also, we may have a force that is known as field force, like the gravity force. This gravity force, this is what makes us not flying in the sky, like going to the space. For example, thanks to this gravity force, we already can live over the earth. So this is the gravitational force between our body, our mass, which is a very little small mass, and the huge mass of the earth. So there should be a gravitational force. According to the Newton's law of gravity, we do have this force that needed to keep us over the earth's surface. Even if you try to jump, you're gonna fall down again. Why? Because of the gravity force. But this gravity force, it is a field force. It is a different concept of the force. For example, if I ask you who is pushing who, the earth or you, like your body, is pulling the earth, or the earth is pulling you because of the gravity. Who is pulling you? The other. Both are pulling each other. Your body is attracting the earth as the earth attracts you with the same amount of force. This is the concept of the gravity force. It means that the gravity force, it is that this little small mass is going to be attracted to the earth, and the earth is going to be attracted to the small mass as well. So this is the physical meaning of a field force that gives and take. It is equivalent. Both are affecting each other. Okay? Anyway, forget about this detail. So this is a typical example of this case, like the gravity force, for example. Also the electrostatic force. Electrostatic force, it is one of the forces, electrostatic force. This force, it generates between two different charges. If we do have an object with a negative charge, the other one with a positive charge, there should be some forces generated between them. Who's going to be attracted to the other? Both will be attracted to each other. It means that the negative is going to move towards the positive. The same thing for the positive is going to move toward the negative charge. But the movement, it couldn't be clearly seen as for the case of the positive, because the positive, it would be huge. Very same this like the concept of the earth. For example, if you try to jump in the sky, who's going to be moving toward the other? Your body is going to move to the earth. Why? Because the earth is huge mass. But this doesn't mean that the earth is not attracted to your body. No, the earth is attracted to your body as long as you are attracted with the same attraction force as your body is attracted to the earth. But the thing who is capable to move toward the other is your body. Why? Because your body is lower mass. The same thing for the electrostatic force. Both charges will be attracted to each other, but the negative charge, for example, because this object is smaller mass, so it's going to move toward the positive charge. If the positive is smaller, the positive is the one who is going to move toward the bigger mass. So the mass, it should be considered in this case. But anyway, something that you should understand about the field forces like gravity force and electrostatic force, that the two objects are attracting each other. Not just one attracting the other. No, both are attracting each other with the same amount of force. For the magnets, it is a little bit different. The magnet is the thing that attracts the iron or the metallic material, the metal. Metals are attracted to the magnets. So there is a magnet, and the magnet is going to attract the iron. The iron cannot attract back. So it is not like the field or the electrostatic force. No, it is a different thing. There is a magnetic force. This is magnetic force. But for this magnetic force, the iron is the one who is going to be attracted to the magnet because of the magnetic force. But in general, the objective here is just to know that we do have so many different forms and more than these types and forms of forces. We do have forces which can be considered as mechanical forces, like the impact force, tension force, spring force, even the gravity force. It is just a force. We can deal with it as mechanical engineer, but it is commonly known as field force, which used more in physics classes, like the electrostatic force and the magnetic forces. So these forces are used a lot in the physics class, but in the mechanical application, especially the mechanical design, and this is our main concern, definitely these are some of the types of commonly used mechanical types or forms of forces that you should consider when you do design for any mechanical component. Make sense? So these are different types of forces, and what we have covered so far, we were discussing what does it mean a force and these different forms and types of the forces. All right, so let us fix some concepts here, some things. As I said, this topic of the force analysis, some of you already have finished the statics class. So for them, what I'm saying, it is very simple. It is very logic. They had experienced these things and more complicated things even in the statics class. But many of you didn't study the statics yet. So that's why you have to focus on these things and know how we can do force analysis. Okay, so the force analysis actually is just to, what does it mean, a force analysis? First of all, force analysis is to find any unknown force. If we're gonna talk about the, for example, mechanical components like gears, to find the forces that is hidden between two gears in any machine, can you see any force? No, the force, it is something logic, it is something virtual, not exist in reality, but it's affected there. What makes one gear rotate the other one is a force. We cannot see this force by the naked eye, but we know that there should be a force between these two mechanical components that needed to change the state of one gear and the other one to rotate them. Make sense? So what does it mean, a force analysis in general? Force analysis is to find any unknown forces. Is to find any unknown force. This means that if you have a machine or a mechanical component that is subjected to some forces, this mechanical component could be subjected into different forces, not just one force. So many forces, but some of them will be known, no problem with these forces that we knew their values, but some other forces will be unknown. To find these unknowns, it means that you have done and finished the force analysis. This is what does it mean, a force analysis. Like, for example, if we consider this mechanical component or this hook, it is subject to three forces through three wires. Like this, these three wires are connected in this ring and pulled in three different directions. So if one, it is one force, if two is another force, if three is the third force. So these are three forces. You probably, for some reason, know one of these forces, but you don't know the others. Or you probably know two forces and you don't know the third. To find any unknown force is known as force analysis. Make sense? So finding the unknown forces that acting on any mechanical component or any engineering system is known as force analysis. Make sense? So let us try to fix some concepts here, and let us consider this very simple example of the box that we just explained over that guy who was pushing the box. So this is example number 1. Assume that we do have this box. You do have a box that is sitting on the ground. And for some reason, we already affecting or pulling this box with a force as F1. So F stands for F, force. 1 is just to distinguish one force from the other one. So this subscript just to distinguish the different forces that acting over this box. One force is given by 10 Newton. If you remember from the previous video, we said that the unit for a force, it is Newton, which is equivalent to kilograms per meter per second square. And it means that we are working with the international unit system. And there should be another force on the other side, which is F2. F2 is given by 20 Newton. Assume that. So it means that this is like someone already pulling the box from this direction and someone else pulling the box from the opposite direction, but this force is 10, but this one is 20. So if I ask you, forget about physics, mathematics, engineering, anything. If I ask you in which direction this box is going to move, definitely is going to move to the left. Why to the left? Because this force is bigger than this one. So to know this and to express this in terms of mathematics and equations, we need to solve. So for example, if the requirement, this is what is required. It is required to find the sum or the net force, or the sum of the forces acting on this box, how much it is. So all of these forces are affecting in one parallel direction. This direction is horizontal. It means that these two forces are two horizontal forces. And since we are engineered, that is fine to assume that you do have a coordinate system. So this XY, this is known as coordinate system. If we are working in 3 dimensions, so we should have like X, Y, and Z, like we're working in space. X, Y, Z, this is known as coordinate system. If we are working in 2 dimensions, so we're just gonna have only the x, y, and then we can cancel the z direction. Assume that it is not there, but it definitely it is there, but we're just working in the 2 dimension. So assume that we do have the x, y coordinate system in the 2 dimension. So in which direction does this forces, or each one of these forces, parallel to the x direction? Or which direction? Is it parallel to x or y? It is parallel to x. Why? Because this one is horizontal, this one is horizontal, and it is clear that both are parallel to the x-axis. So to calculate the sum, this is how we calculate the sum. So to sum these forces together into one component of a force, into one force, you need to sum. So this symbol indicates that this is the summation or the sum of the force along x direction. So here I'm summing the forces along x equals. How much? This is the net force that is required. This is the net force, or the sum of the forces. This is the sum of the forces, the summation of these 2 forces. I would like to combine them in one force. Like one pull from one direction with 10 Newton, the other one pull in the other direction with 20 Newton. For some reason, I would like to combine these 2 forces into one force. How much it is? This is the net force. Make sense? So then one of these forces is going to be positive and negative. So this positive and negative, this sign indicates a direction of the force. For example, if I assume that any force going to the right in the same direction as positive x, this is the positive x direction, and this definitely is going to be the negative x direction, right? So this is the positive x, this is the negative x direction. So I'm going to assume that any force that is going to the right in the same positive x direction is going to be positive, and any force going to the left is going to be negative. I am assuming that, but you can change this assumption. Like, for example, you can assume that any force going to the positive x is negative. So the other force in the other direction is going to be positive. It means that it is not necessary all the time. It is not necessary all the time to consider the force in positive x to be positive. No, you can assume that force negative, but the other one, it should be positive. So you're just going to take any direction as positive, the other one is going to be negative. It's up to you. Choose any direction positive, the other one will be negative. Make sense? So I'm just going to assume any force going in the positive x as positive, like the F1. So F1 will be positive. Why? It going to positive x direction, and this is what I assumed. So definitely F2, which is directed, the arrow direction indicates that it goes to the left, to the negative x direction. So I'm just going to consider it negative. I assume that. Equals. The F1, it is already 10, so it's going to be positive 10 Newton. Negative the F2, it is already 20, so this is going to give us negative 10. How much is the unit? It should be Newton. As I discussed over the previous video, the force, it is a physical quantity. Any physical quantity to be fully described and correctly described, it should be described by a number followed by a unit. If you don't add the unit, this number doesn't make sense. What is 10? Is it 10 meters, centimeter, Newton, kilonewton, meganewton? No, it is 10 Newton. To be more accurate and specific, so the unit, it should be added. So let us discuss this number or this force value that we got here for a while. So it has 3 parts, 3 things. There is a sign, there is a value, and there is the unit, as I said, to give sense to this number. The sign indicates a direction of the force. So what does it mean? This net force, it is negative. What does it mean it is negative? It means for some reason, if I decided to replace this box, with the 2 forces with only one force, assume that you have the same box, but instead of acting on it with 2 forces, I decided to combine them in one force. This one force is known as the net force. How much it is? We got it by 10 Newton. But what is the negative? This negative indicates that this direction of the force, it should be in the negative direction that you assume. We assume that the negative, it is negative x. So it means that this force, the sum of forces along the x, it should go excuse me, should go to the left by the negative 10 Newton. This negative indicates that it goes, I can remove the negative after that. It means that since you already defined, and we're going to discuss this with more detail, there is no need to this sign to be added because we already defined the direction by the arrow. It means that this force is already going to the left with 10 Newton. It means, for example, if you have this box, and there are two guys, one pulling this direction with 10, the other one pulling this direction with 20, this box is going to move to the left while the 20 is bigger. It's gonna move the same speed, with the same velocity, with the same acceleration, the same way, in case that would have only one guy pulling the same box to the left with 10 Newton. So these two systems are equivalent. This one is equivalent to the original system. We replace the two forces with one force. This is what does it mean, a net force. And this is what does it mean, the negative. The negative or the positive indicates it is not related to the value as much as it is related to the direction of that force. Is it right or left? Make sense? According to your assumption. What is the value of the 10? This 10 is known as magnitude. We are giving it a name as magnitude. The magnitude of this force, this is the value of the force, how much it is, how much of force do we act or pull or push this box. The N stands for the unit, as we mentioned, this is the unit that makes sense to this value. So this is simply how we can calculate the net forces acting on any object in case that it is subjected to multiple forces. And according to this, the net force as seen here, it is bigger. The net force, the sum of the forces is bigger than zero. I'm talking about the magnitude of the force. What does it mean, the magnitude? The value of the force. We are adding this absolute value to get rid of the negative. So the value of the force is bigger than zero. It means that the sum of the forces is bigger than zero. This means that the state of this object is going to change. It means that this box is going to move according to Newton's first law. Why? It is subjected to a net force bigger than zero. The magnitude of that force, it is bigger than zero. It is 10, not zero. But for some reason, if this guy on the right pulls with 10 and the other guy also pulls with the same force, so this box will not move. Why? The net force will be zero. 10 will be cancelled to 10. It means that the box won't gonna move. It means that there is no change in the state of this object according to Newton's first law. Make sense? Let us consider another example here. Example 2. How about if we do have a box that is sitting on the ground, and there are three forces instead of two forces. One force is 15 kilonewton directed in this direction, and the other force is 20 kilonewton in the same direction to the right, and there is one force acting on the left as F2. And F1, this is like F1, and this is like named F3. So these are three forces acting on the box. We knew two of them. One of them is 15 kilonewton, the other one is 20 kilonewton, but this second force, F2, we have no clue how much it is. And it is required, in this problem, it is required to find F2 that makes the net force along X equals 0. This is the condition. It's just to find the F2 that makes the net force along the X direction is 0. Okay? So it means that your objective is just to solve the net force. It means that we need to find this F2. It is unknown. If we found this unknown, it means that we have done force analysis. This is what does it mean, force analysis, as we explained, to find these unknowns. So the condition is that the sum of forces along X direction, it should be 0. This is the condition, equals. If I ask you to sum the forces along X, how many forces do I have parallel to X? We do have 3. We do have F1, we do have F2, we do have F3. These 3 forces should be summed together. The summation doesn't mean it should be plus added. No, the summation, it could have a positive sign or a negative sign. This is what does it mean, a summation. So they have three forces that we have to sum them together. Some of the forces could be added with a negative sign, some of them would be added with a positive sign. Depends on what? Depends on the direction of the force, and according to the direction that you assume is positive. Which one is direction is positive, which one is negative. So it's up to you. So let us do as we have done over the previous example, that I'm going to consider any force in the positive x direction to be positive, any force in the opposite direction will be negative. This means that the force F1, which is 15 kilonewton, will be positive. F3 will be positive, but F2 will be negative. Why F2 is negative? Because it is in the opposite to the positive direction that I assume, which is going to the left. This sum of all of these forces should equal to 0. Then, how much is F1? It is 15 kilonewton. Negative F2, we have no clue how much it is. Plus F3, which is 20, equals 0. This is gonna give us an equation, right? This is from mathematics, it is equation. And this is why you should study mathematics. Because to solve this equation, despite it is very simple algebraic equation, but definitely there are some other engineering system that should be described by more complicated equations. So you need mathematics to solve this equation. So what I've done here, and this is very interesting thing to know, what I've done here, I've converted this real system, this is the real system, right? Which is a box that is subjected to some forces. I've converted this real system into a mathematical equation, known as mathematical model. And I've mentioned this once in one of the videos before, when we were discussing the engineering design. It means that I've converted this real system into some simple equation that then we can solve it. To solve this equation, this requires, now we need to solve. To solve, this requires mathematics. This is the importance of the mathematics. This is why you study some of the courses in your curriculum for mechanical or industrial engineering includes mathematics. Why you study mathematics? To be able to solve this equation. But if you have zero knowledge in mathematics, you're gonna stuck here. You aren't gonna proceed more. You aren't gonna able to accomplish and finish the force analysis. The force analysis, it means that you have to find this unknown force. So that's why you need mathematics. So then to solve, if you use mathematics to solve this simple equation, we can simply find how much of the force. Simply if we combine or sum the 15 plus 20, this gives 35. Negative F2 equals 0, then simply you can move this F2 to the right side. I'm pretty sure that you can, these things are very simple to use. So F2, this gives F2 at 35. And the F2 will be 35 positive. Positive, it means that it will have a certain direction, and we are going to discuss this direction. But is it fine if I just write F2 equals 35 in this way? No, you should add a unit. What should be the unit here? We mentioned once before that the force, it has a unit of Newton. But the forces as given to me in the problem, all of them were given in kilonewton. And I didn't do any unit conversion. This means that you just gotta carry on the unit as it is given. I didn't change this unit from the start of the problem. I'm using the same unit as they are given, as they were given to me. 15 kilonewton, 20 kilonewton, definitely this force will be kilonewton as well. So as long as it means that for example, if you are solving any mathematical model for any engineering system, and the unknown is a force or any other physical quantity, and you find a value, use the same unit at the other values or forces in the same problem. Like all of these forces are kilonewton, so it will be kilonewton. If all of them are Newton, it will be Newton. If all of them are giganewton, it will be giganewton, and so on. So this is the importance of the units, and this is the unknown. Once you find this one, it means that you have done a force analysis. So simply force analysis is just to find these unknown forces. Make sense? So this is a very simple example how we can drive or find any unknown force that would acting over this box. Make sense? One last example that we are going to consider here, example number 3. Let us assume that you still have the same box, but now the box is like kind of not sitting on the ground. It is like hanging in air. Like this is the box. And for some reason, this box is subjected to different, like around 6 forces. One force in this direction as 10 kilonewton, and there is another force in the same direction by 15 kilonewton. And in the opposite direction, there is a force of 8 kilonewtons. And there is a force in this direction by 20 kilonewton going up. And there are 2 other forces acting or pushing this box down. One is 5 kilonewton, while the other one is 7 kilonewton. So it is required to find the net forces acting on the box in directions X and Y. So definitely if we assume a coordinate system, this is going to be X and there is Y. So the difference between this example and the previous ones actually that we were having this box that was subjected to some forces, all of them were acting along the X direction or in one direction. Like in this example, all of them right or left, it means horizontal forces, and here also horizontal forces. But here we have some forces who are horizontal forces, and some others are vertical forces. What should be the net force along the X direction, which is the horizontal force, and the Y direction? So this gives in mind something that is it fine. So in total, this box is subjected to 6 forces. How we can combine these 6 forces into one force? Can we do it? Yes, we can. But it requires some steps that I will not explain now. But for this case, the objective is just to sum the forces along X, sum the forces along Y. So this brings another question. Is it fine? Does it make sense that you collect all the forces who are horizontal in one force, and then you collect all the other forces who are vertical in another force? Yes, we can. So it means that when we sum the forces, we have to acknowledge the direction. Is it parallel, or is it parallel to X, or is it parallel to Y? Or is it horizontal force or vertical force? We don't care whatever it is, goes right or left, up or down. We don't care about it. We're gonna consider them in this direction, right or left or up or down in this sign. But when we sum, we have to sum all the horizontal forces together in one component and the vertical forces together in another component. But you cannot sum all of them in one component at once. It is wrong. It doesn't make sense from physics. So for example, I cannot sum 20 plus the 5 and the 7 and the 8 and the 10 and the 15 in one force at once, in one step. No, it should be done over multiple steps. So for example, the first step, that is fine to combine the X components first, or the Y component first. It doesn't mean which come first, but anyway, the Y forces should be summed together and the X forces should be summed together first. Then we are going to combine somehow these 2 net forces that you're going to find the net force along X and the net force along Y. Then you're going to combine these 2 net forces in one force. It requires a procedure. Make sense? That it will be explained later. But for now, let us just calculate the force along X, the force along Y, and that's it. So the sum of the forces along X, this is the net force. This is the net force along X direction. So how many forces do we have parallel to X? We do have 3. I'm just going to assume as usual, any force going to the right to be positive, the second one is going to be negative. It means that the 10 is positive, the 15 is positive, the 8 will be negative. So the 10 is positive, the 15 is positive, but the 8 is going to be negative. If you sum these forces, you're going to end up with 17. So this is the net of the forces parallel to X only. I didn't sum or add the other forces, the 3 forces. Why? Because they are directed in a different direction. They are not parallel to the X. They are not parallel to the X-axis. Instead, they are parallel to the Y-axis. There is a totally different direction. So I cannot sum them at once. I can only sum the X directions and then the Y directions. What should be the unit? It should be kilonewton. So this is the net force along the X direction. Why kilonewton? Because all the forces as given to me are in kilonewton. So this result, or the force that you're going to calculate, definitely is going to be both the number and add the unit directly as it is given. How about the net forces along Y? So this is the net force. This is the net force in Y direction, or along Y direction. How many forces do I have parallel to Y? Would have 3 forces. You're just going to assume one direction is positive, the other one is going to be negative. I can assume that any force going up is positive, the other force that goes down is going to be negative. It's up to you. So let us assume that any force going up, like the 20, is positive. So definitely the 5 and the 7 will be negative. So -5, -7. If we did the calculation, this is going to give us at the end 8 kilonewton. Why kilonewton? Because the unit of the force is already kilonewton. And why it is 8? Because 20 -5 -7 gives 8. Very simple. As you can see, this is the net force, this net force along X. It means that I somehow combined all of the 3 forces acting in the box. So if I decided to draw the box again, all the forces acting on the box along X direction were combined in one component as 17, and it is positive. This positive indicates that it goes to the right. Why right? Because I assumed the positive in the right direction. So this force, 17, is going to go to the right. Kilonewton. It means that I've replaced all these 3 forces with only one force. How about this sum of forces along Y? I have replaced the 3 forces along Y direction with only one force that is also positive. It means that it is directed up. It goes up in this direction by 8 kilonewton. So it means that this box, it is subjected in total. We have combined these 6 forces into 2 forces. One in X, one in Y. That this box will be pulled in the X direction, positive X, and it will be pulled in the positive Y direction. So if I ask you, is this box is going to move or not? Yes, it's going to move. Why? The net force acting on it, it is not 0. Despite there should be one more step to calculate the sum. So the question is, I have summed all the forces along X, I have summed the forces along Y. Can we sum or combine these 2 forces in one force? Yes. This requires the calculation of a force known as the resultant force, and this is what we are going to discuss over the next video. But for now, we're just discussing how you can sum forces in one direction together, like X direction and Y direction. You cannot sum all of the 6 forces at once. No. You should sum the forces along X first, then you sum the force along Y first, then we can combine these 2 forces in a resultant force, known as the resultant force, and this is what will be covered over the next video. Make sense? So because of these forces, it is expected that this box is going to move in this direction, because there is one force pull in this direction and another in the Y direction, so it will fly in the space in a direction, in this direction, kind of. Make sense? So that's it for this video or today. The next meeting, as I said, I'm going to show you how we can calculate the resultant forces. If you have this force and this force, how we could combine them together in one force. So, and then also in the meanwhile, we're going to discuss the forces as a magnitude and direction, or as a vector, and we're going to explain this point with more detail over the next video. Make sense? So the next video, for example, we're going to consider this example with more detail and similar ones for the force analysis. Remember that the force analysis is just to find the unknown. So what we are doing here, all of it is force analysis. And there should be, these similar things. You have to do similar things, but more complicated for the mechanical components. To understand and find the forces that generate between these different components, you should do similar things. Calculate the forces along X, calculate the forces along Y, do this force analysis. This is the first step in the mechanical design calculations. Make sense? So that's it for this video, and thank you so much, and see you in the next meeting.